All right, last section. This video is going to cover section 5.5, which is exponential modeling. So we left off with 5.4, which is talking about some of these. So it's kind of just an extension of that, of the word problem type thing. So according to the 2010 U.S. Census, the population of Vero Beach was 15,080. The 2020 U.S. Census found the population of Vero had grown to 17,104. Use the exponential growth model. Y equals y sub 0 e to the power of k times t, where t is the number of years after 2000, to write the exponential growth function for the city of Vero Beach. Round the growth constant k to 4 significant figures. All right, so we kind of need to find this. So what it's saying is, all right, the population of Vero was, okay, so according to 2010, the population of Vero was 15,080. In 2020, the population was grown to 17,104. Remember, t is the years after 2000. So it's saying we're starting off with our y sub 0 being 15,080. Okay, so that's that. So y equals 15,080 e to the k times t. We need to find k. But it gives us that in 2020, which will tell us 10 years after 2000, so t is the number of years after 2000. So this is saying when t is 10, our population, or y, was 17,104. Let's plug that in. So 17,104 equals 15,080 e, k, I don't know k, but my t value here is 10. We can now use this to solve for k. So let's get e by itself. Let's divide those sides by 15,080. Those cancel. Let's see if I can write this. 17,104 divided by 15,080. Ugly decimal, so just leave it as a fraction. So 17,104 divided by 15,080 equals e to the k times 10, so 10k. I want to get e's by itself, so I want to bring the exponent down out front. It's e, so we can use the natural log, take the natural log of both sides, and in doing so, that exponent's going to come down out front, going up here. So natural log of 17,104 divided by 15,080 equals that 10 times k is coming out front times the natural log of e, which we know the natural log of e is 1, so that cancels out. So we're left with 10 times k, getting k by itself. We can divide both sides by 10. We're left over with k by itself. So k equals the natural log of 17,104 divided by 15,080 all over 10. Let's plug this into our calculator. Natural log 17,104 divided by 15,080. That's all we're taking the natural log of, so close your parentheses, divided by 10. It says round k to 4 figures, so 0.012, and then 59 will round up to 6. So that's our k. And the question asks us to find the growth model. So writing it. So our equation is y equals y sub 0, which we said was 15,080, e to the k, which is 0.0126 times t. Y and t are like x and y, so leave it like that. E is just our number. That's our final answer. So next says use the population growth model. Let me give you a second to write that down. Hold on one second. All right. Because it says 4 significant figures, it's saying that 0 is not a significant figure. So let's go one more number. So 1, 2, 5, 9. I don't like the way it's worded. On the test, that would have been fine, but just on the homework, I just want to let you know. 0.01259. So whenever it says significant figures, it doesn't count 0 as a figure. So it wanted 4 numbers. So 1, 2, 3, 4. So this is 0.01259. All right, I just wanted to make sure that was right with what the homework says. Use the population growth model to predict the population of Vero Beach in year 2027, round to the nearest whole number. So remember, our time is the years after 2010. So 2027 is 17 years after 2010, so it's telling us plug in 17 for t. So y equals 15,080 e to the 0.01259 times t, which in this case we're going to plug in 17. 15,080. Second ln will give us e to the power 0.01259 times 17. And that will give us, rounding us to the nearest whole number, 18,679. So that'll be our population, 18,679. All right, last one. Determine the year when the model predicts the population of Vero to be at 28,528, rounds to the nearest whole number. So determine the year. So we don't know t whenever the population, so that'll be our y, will be 28,528. So going back to our equation, so our y is going to be 28,528 equals 15,080 e to the 0.01259 t. So getting that e by itself, we can divide both sides by 15,080. That does cancel. So 28,528 divided by 15,080 equals e to the 0.01259 times t. It's base e, and I got that e by itself, so I want to bring the exponent down out front. Let's take the ln of both sides, and in doing so, this exponent is going to come down out front. So the natural log of 28,528 divided by 15,080 equals 0.01259 times t times the natural log of e, which we know the natural log of e is just 1, so it cancels itself out. We're trying to get t by itself, so you can divide both sides by 0.01259. And those cancel. So we got t by itself, so we know that t is equal to the natural log of 28,528 divided by 15080 all over 0.01259. So many numbers. Let's plug this into our calculator, round to the nearest whole number. Natural log 28,528 divided by 15080, closing our parentheses, that's all we're taking the natural log of, divided by 0.01259. And that will give us, rounding it to the nearest whole number, should be 51. Should be 51. Now remember, be very careful, because it doesn't say find t, it says determine the year. So 51, that means 51 years after 2010. So 51 years after 2010 will give us 2061. So in year 2061 will be when our population is 28,528. So be very careful there. All right, let's do another one. 2 more. Yep. The doubling period of a bacteria population is 35 minutes. After 70 minutes, the bacteria's the bacteria colony's population has grown to 34,693. Determine the initial population of the bacterial colony round to the nearest whole number. All right, so a couple things here. One second. So this is still growing exponentially because it's bacteria. So let's use the same PERT formula. I will give it to you on the test if it's not on there. All right, so it's saying the doubling period. So it's saying that our amount is going to be our original doubled. So 2 times P in 35 minutes. So our amount is going to be 2 times our principal, P equals our rate. We don't know our rate, but in 35 minutes. So our T can be 35. All right, let's try to get E by itself. I can divide both sides by P, and that way those P's cancel. So we're left with 2 equals E to the power of R times 35, or 35R. So I want to bring that 35R down out front, so I can take the natural log of both sides, and that will bring that 35R down out front. So the natural log of 2 equals 35 times R times the natural log of E. The natural log of E is 1, so that cancels out. We're trying to get R by itself, so we can divide both sides by 35. That would just cancel. So our rate, R by itself, is the natural log of 2 divided by 35. Natural log of 2 divided by 35. And that will give us 0.0198. So plugging this back in, now we know that A equals PE to our rate, which is 0.0198 times T. We're trying to find our initial population, so we're still trying to find P. It gives us something else. So after 70 minutes, so now this is a T value, the bacteria will grow to, this is a new A value of 34,693. So let's plug that in. So our new A is 34,693 equals P. We don't know P, that's our initial population that we're looking for. E to the 0.0198 T, which they said was 70 minutes. So E to the power of 0.0198 times 70 is just a number. So we can divide both sides by E to the 0.0198 times 70. I don't want to round, so that's why I'm leaving it as ugly numbers. That way those cancel. And we got P by itself, which is what we're looking for. Coming up here. So P equals 3493 divided by E to the power of 0.0198 times 70. So I can plug this into our calculator exactly like we see it. 34,693 divided by second ln, which will give us E to the power 0.0198 times 70. Round to the nearest whole number. And that will give us 8,676. Sorry, 1 second. All right, I just want to be super, super exact. So if I were to plug this in, so natural log of 2 divided by 35 will give us, let's put more numbers, 0.0198042052. I know it's like super annoying, but look, so because then whenever we divide, this number here is 0.0198042052. Now when we divide it, 34693 divided by second E to the 0.0198042052 times 70, it gives us a little bit different answer. So remember when I said don't round to the very end? This is why you don't round to the very end. So just make sure that I only did 4 decimal places. Probably do more than 4. Probably do more than 4. I was just being lazy. I'm sorry. Honestly, the weather's getting bad and I want this video to work. So that's why I'm trying to hurry. So don't round to the very end. That's why it gave us a different answer. So now last problem for this part, determine the population of the bacteria colony after 4 hours, round to the nearest whole number. Notice up here it said in minutes. It was in minutes. So we need to turn this 4 hours into minutes. So 4 hours, if there's 60 minutes in an hour, will give us 240 minutes. So that'll be our time that we can plug in. So our new formula will be A equals P, which we just found, 8673, E to the 0.0198042052 times 240 minutes times 240 minutes. I kind of squished that with this one. So let's plug this into our calculator. 8673, second ln, 8673, second ln e to the power of 0.0198042052 times 240 minutes. And that will give us our final answer, round to the nearest whole number, of 100,548, and then that 3 is going to round up to a 4. So that'll be our population. All right, one last problem. And we're done with this whole homework. The half-life. So before I was talking about doubling, now it's going to be the half-life of Krypton 85 is 10.72 years. After 7 years, a sample of Krypton 85 has been reduced to a mass of 95.3945 milligrams. What was the initial mass of the sample? Rounds to the nearest whole number. So it's just like the previous problem, but this time instead of double, it's going to be half. All right, so our compound continuous formula is A equals PE to the RT. It's telling us half-life, so our amount is now going to be half of what we started with, so half the principal. In the time of 10.72 years. So our A, which is half of P, will equals PE to the rate times 10.72 years. All right, just like the previous problem, getting E by itself, let's divide both sides by P. That way those cancel. So 1/2 equals E to the R times 10.72. E is by itself. Now I need to bring the exponent down out. So let's take the natural log of those sides. That will bring this exponent down out front. So the natural log of 1/2 equals R times 10.72 times the natural log of E, which we know the natural log of E is 1, so that cancels out. Getting R by itself, we can divide both sides by 10.72. That would just cancel. So our rate is the ln of 1/2 all over 10.72. Now we're going to learn our lesson. We're not going to round this time because it's going to mess up our answer. So natural log of 1/2 divided by 10.72. Notice that 1/2's in parentheses. That's all we're taking the natural log of. And we're left over with negative 0.0646592519. Super ugly, but it's fine. All right, so now that's our rate. So going back up here, so A equals PE, our rate is 0.0646592519 times T. It's asking us what is the initial, so what is our P value? I don't know, but just like the previous problem, it tells us after 7 years, so it gives us another T value. The mass has been reduced to, it gives us another A value. So our A value is 95.3945 equals P, we don't know P is, we're looking for P, E to the negative 0.0646592519 times T, which they're telling us is 7. Ugh. So remember, e to this stuff is just some number. So I can divide both sides by e to that stuff. Times 7. That way those cancel, and we can get P by itself. That's what we're looking for. We're looking for the initial, we're looking for P. So P equals 95.3945 all over e to the negative 0.0646592519 times 7. Super ugly. I agree, but we're doing it. So 95.3945 divided by second ln, which will give us e to the power of, you want to know a little trick? So I want to put that number in, right? So if I do second and then I do answer down here, second, which is negative, it'll plug in that previous answer in there. So it'll plug in that negative 0.06, so that's kind of cool. So it'll save you some time, times 7. And that will give us our answer. Rounding it to the nearest whole number, which is 150. So our P value is 150. Done. So these are just the same thing we've been doing, just like it's talking about real life scenarios. So the numbers are just ugly. So use the mass of the sample. What is the mass of the sample 7 years after it was created? Round your answer to 4 decimal places as needed. So it's telling us that T is 7. So I can plug into my equation, T is 7. So my equation now is A equals P, which is 150, E to the rate, which is negative 0.0646592519, and then plugging in 7 for T. All right, so 150 times second ln E negative 0.0646592519 times 7. And that will give us our final answer. And it says round to 4 decimal places. So we get 95.3945 as our final answer. And guess what? We are done with all of chapter 5. And that's the rest of, this is the last note section of this whole course. So congrats, you made it this far. So thank you very much for watching. If you have any questions, please let me know. If not, we will get ready for test 4, our last test before the final exam. Thank you again for watching.